Hi there, this is Dr. Everybody with Project 5, and this project will be doing some reading of files. We will work with functions. There's what might seem to be some scary math in here, but we give you all the formulas. It's actually what gets called linear algebra, but you don't need to know any linear algebra to do this because we tell you how to do stuff. The one thing that's unique about this project as compared to most projects that deal with files is that here, when we're reading a file, we usually read the whole file. Go through and read the whole file. Here, we're going to, the functions that access the file are going to read just one line of the file. And so the way those functions will work is that you'll go to the beginning of the file and then go down to the line that is of interest and extract data out of that one line and return those values. So that's a little unusual. And then we have some functions that do some things like cross products and stuff like that. So let's take a look at the project. The idea here is that in the field of computer graphics, there's a lot of figures drawn, right? And one thing that's common out of this is that a lot of what's drawn for pictures involves a lot of little triangles. All right, so here we have a picture of a porpoise, and you can see on there's a lot of triangles. So what we're going to do is we're going to actually do some of the math involved working with these triangles, and that's what we're doing in this project. So what's involved in this? Well, all of these triangles, of course, have, as you know, they've got three sides and they have three vertices. Right? So in this case, here's a triangle ABC, and it has vertices A, B, and C. Side 1 is actually the side that connects A and B, and side 2 here is the side that connects A and C. And then we have what's called a normal, which is the cross product of side 1 and side 2. And you can't really see it here, but imagine this triangle is in a plane and this normal is sticking up vertically out of the plane. That's the idea. And that normal ends up being important for the graphics. So one of the things that we're going to have to do is to construct that normal. And to do that, we're going to have to, out of our file, read the 3 points that we need, and then use those points first to create one side out of A and B, and then the other side out of A and C. And once we have those two sides, then we can do this arithmetic. So notice the steps there. Get each vertex. And it turns out we have these, we have to read those out of the file. And then once I have those vertices, I can create the sides. And once I have the sides, then I can do the cross product. So how might I in fact go about doing that? Well, how do I represent a side such as AB? Well, if A has 3 coordinates, remember, so this is in three-dimensional space, so you have 3 coordinates. So imagine it has an A1, A2, and A3, and B has coordinates B1, B2, B3. Then that side, AB, is the difference of those. And so now I have 3 coordinates there that are formed out of points A and B, and that represents that side AB. All right, now once I have the two sides, then let's say we got this little cross thing. That's called a cross product. So I have I have these two sides. Remember, each one has an x, a y, and a z coordinate. So we've got our 3 coordinates. So I have 2 of these. So v1, v2, 3, that's the x, y, and z of each of these. And then, so what is the cross product of that? Well, let's take a look at that. We can slide this down a little bit. And now, how do I find the cross product of these two sides, right? They're called vectors, but these are the sides here. And each one has 3 coordinates, and all we do is, we again come up with 3 coordinates, the x, the y, and the z here. And the first one takes v2, that's that guy, and w3, that's that guy, and then v3, that's that guy, and w2, which is that guy, and that makes up the first component, the x, and so on. You just follow through there. So when you're going to write a function called cross product, it's going to take 2 of these sets of 3 values here, and then it's going to come up with 3 values, the x, y, and z. That is the cross product. So you just have to follow this formula, and it's pretty straightforward there. However, one thing you might think about, we talk about problem solving as a task here, separate from writing the code. And what we do is we encourage you to work with somebody as long as you're talking about the problem. As soon as you start talking Python details, then you need to be working on that by yourself. But these steps that I just outlined here, you want to sit, you should sit down with somebody and say, okay, I got to do this cross product function. If we get down here, we can see, there it is. There's the compute the cross product. And you can see it's got v1, v2, v3, and w1, 2, and 3, just like we saw before, and it returns 3 values. How do you, in fact, do that? Well, you could write that formula down in math and English, and that then makes the coding of it a lot easier. So what I like to do next is take a look at the file itself. Now we sort of draw a picture here, but let me go in, and I'm on a Mac. On a Windows machine, you would do something similar and actually take a look at the structure of the file. So there's the whole file. Let me blow it up a little bit. And notice the organization that it has. Okay. It starts off, the first line is the word off. All right. And then the next line, it has 3 values. The first one says that there are 22 values here. Okay. All right. So these are the actual vertices, and these are triangles. And so this says this is a triangle made out of vertex 2. That'd be the second one down, 3, and the 0. So these are obviously starting at 0. So you have vertex 0, vertex 1, vertex 2, vertex 3, and so on down. And what we end up doing is we will we will first of all find a triangle, and it has 3 vertices, and so then we have to go and grab the vertex that's at index 6, and then go back and grab the vertex that's at index 5, and then go and grab the vertex at index 1. And we have functions to do that, but so I will go through, I will grab those. Each of these has the x, y's, and z's with it, and then we can use those to do our computations. We take advantage of the fact that that the structure of this file, right, starts with a word. It has how many of these vertices here, and so I can skip if I'm trying to find a particular vertex here, I can skip these first 2 lines, and then just with a for loop, I can go down to the particular one I'm interested in, read those 3 values, and return them. If I want to find a face, one of these triangles, then I know I got to skip past the off line. I got to skip past the count line. I actually know how many of those there are, and I can skip past all these and then start looking at which particular face I'm at. Or you can use the fact that if a line begins with 3, then it must be one of my faces. So you can just skip past everybody until you get to that point. However you do that, you get to choose. So there's a little bit of a look at the math. That's a little bit of a look at what's going on in there. We do give you some starter code. And what I'd like to do is take a look at the function that reads a vertex. That means, and notice what happens here. I'm given a file, and I'm given an index. So what does that mean that I do? So I go into the file, and I will use that index. So like if I'm given a 5 or something, I need to go down 5 and then return the x, y, and z that's in that line. Let's take a look at how that function would work. And so what do we have to what do we have to do here? Let's take a look at the at what the steps are involved. Okay. So I have a file, and in this particular project, because we keep going back and reading the file, there is, and this, assume it's called FP, there is this thing called seek, to seek the beginning of the file. So we seek a particular line. Now we're going to seek 0. That puts us to the beginning of the file. All right. So as it says, the indices start from 0. We already saw that. And we're going to return the coordinates. There's 3 coordinates there. And so the hint is use FP read lines to skip past the first 2 lines. So the first thing I do is I go to the beginning, and then I skip a line using the using read line. And then I skip another line. And then I'm going to have a for loop. And my for loop, like I say here, for I in range, what goes in here? Well, that'll be my index. Right? So for I in range of my index, then what am I doing? I'm actually going to skip those. All right? So for in that range, what am I going to do? I'm going to skip lines. All right? And what I'm doing is I'm just going through my file, skipping lines until I get to the one that I'm at. And then I need to read that line. And remember, when I read a line, I get a string, and then I can slice to get my my values. And we're told that they have a particular format of 15. So for example, my first one will be, you know, at slice of up to 15, right? And then I have to do this 3 times, right, to give me the x, y, and the z, because there's 3 numbers in the line there, and then I return the 3 numbers. All right. And so here, in a roughly English fashion, I have outlined the steps that are needed to do here. And we can go. We can now, I mean, you can now write that function based upon the steps that I have there. All right, a little hard to read my my writing there. Let's go. Let me get my. Let me actually write this out. See if I can give myself a little bit of working room here. All right. So I am going to get my cursor back here. There we go. Just so I can write. So what did we do here in my function? We did a seek. We did a file. We skip a line. Skip another line. We loop. We loop past all the lines we don't want. And how do we do that? Well, I've got this variable index, and I can just skip lines to do that. Then I need to, now hopefully I am at my desired line. So read that line. And then slice to get my x, slice to get my y, slice to get my z, and then return x, y, and z. And just as a note to myself, remember to make them numbers. And I believe that, right, so remember to make them numbers and return them. So here's an English description of my function, and from that you can you can write your code, and you can do this kind of English description, sort of this pseudocode as it's described, working that with another person, and then when it comes time for you to write your Python, you do that yourself. But you can do the problem solving. Okay, what are the steps that I have to go through to do this? And let me get out here. Let's see here. Let's see. Get rid. No. Wrong thing. Let's go here. And now, based on that, you ought to be able to write out the the steps involved, probably probably the most challenging function in this project is this one here, the compute the face normal, and be careful of the fact that we round it to 5 digits. But in this particular project, that we outline it here, or in this particular function, you can go through those. These are the steps that I described in the formula a little bit earlier to create the normal that we have. So that's creating the normal, and then a little later on we have to compute the area. And then here's an interesting one, which is where you try to figure out whether two faces share two vertices. What are we doing here? Well, imagine this situation. I have a triangle, I'll call it A, B, and C. And now I have another triangle, and maybe it's called X, Y, and Z. And what I'd like to do is what I'm trying to do to determine if they're connected is I'm trying to, for example, find out if these guys are the same and if these guys are the same. Right? And so what I have to do here is I have to say, oh, is A the same as X? And if the answer is no, okay, I can move on. And I say, oh, if B is the same as X, then I need to check that, okay, is C the same as Y, or is C the same as Z? And so what you end up with on this particular one, because it is a Boolean expression, right, we're returning a true or a false, is we're trying to figure out if they have two common vertices, right? Just like this here. So that means they're actually adjacent faces, and what this ends up being is like this just really messy Boolean expression. I think mine went about, it went over like about 10 lines just of and, or, and so on. It gets kind of messy. Anyways, there's some hints. Hopefully that will help you get started with this. Give yourself some time. It's a little messy. Good luck.